Hello, everyone. Happy New Year. Welcome back. Happy New Year, everyone. Today we're going to talk about integration. Integration is um, is a really important topic. It's like one of the pillars of physics and maths. And I knew some families, and whenever the child came to the parents and said, "Oh, mommy and daddy, I met someone special. I want you to meet them," and the first question they would ask, "Do they know how to integrate?" I'm not sure that this is entirely true, but certainly that it is a it shows if a person can integrate, yeah, that means it's a well, it's advanced. It's an advanced. This person is advanced in physics and or maths at least. So yeah. Um, all right. So let's have a look at integration. Integration is part of calculus, as you might already know. And who has done integration in school? Give me a vote. A one for yes, zero for no. Mostly ones. Okay. Has anyone done integration by substitution? Okay. Ah, nice. Integration by substitution. Integration by parts. Yes or no? Integration by parts. Oh wow, that's quite advanced at this stage. I mean, it's just past Christmas and you've already done integration by parts in school. That's I'm impressed. So today, but as I can definitely see a mixture. So a lot of people, some people have done, some people have not. So today we'll be focusing on not so difficult problems on integration. I will be doing basic integration. I will be doing integration by substitution, and I will be doing integration by parts. So these three things that I have planned for today. But just to begin with, I will just explain what the integral is. And even if you have done the integration before, it's still useful. At least when I was your age, I found it very useful when different people explained it to me in different ways. So we start with the antiderivative function. Let me. So you should see my screen. If not, let me know. You should see my screen. So the antiderivative function, the integration is the opposite of differentiation. And if you have differentiation, like I mean, if you do um, differentiation, you can learn differentiation in an hour. Yes, because differentiation, you need to know what? You need to know the basic derivatives. You need to know the chain rule. You need to know the product rule, and you need to know the quotient rule. Now, if a function has a derivative, you will be able to find that derivative using one of the four. Well, usually a combination of these four. Okay. So differentiation in that respect, differentiation is very simple. With integration, I would say integration has almost infinite complexity because integration is very vast. It's enormous integration. So that's easy. And integration is much more advanced. We start with basic integrals. Uh, I would describe integration as an art. It certainly is. In some cases, it just I cannot say that I am very good at integration because I know people who can do so much more, so many more integrals, and it's just like I I open my jaw and say, "Wow, how did you do that? I would not be able to do that." We start with basic integrals, then we have the inverse chain rule. Well, inverse chain rule is substitution. Like, I know they study it in school, but it is substitution. I don't think it's even worth talking about the inverse chain rule because you can do the same thing by a simple substitution. I think substitution encompasses includes inverse chain rule. Then you have integration by parts. And well, there are many more methods. There's uh, flown out of my head. But there are many different methods of how you can integrate. Okay. Now, the antiderivative function. Basically, you are given a function and you're given the derivative of a function. You need to work out the function itself. So, for example, if you are told that the derivative of a function is 3x squared minus sine x plus 3, you need to work out what is f of x. So this is what integration does. The integral is the reverse derivative. And you could probably very easily guess what the function was. So 3x squared, which function has a derivative of 3x squared? Well, it's x cubed, right? X cubed. Which function has a derivative of minus sine x? Well, it's cos x. Which function has a derivative of 3? Well, that's 3x. Now, this is not the only function that has this derivative. Because if you do, I don't know, plus 7 here, the derivative is still that. Because the derivative of 7 is that. Instead of 7, you could have ln 8 or whatever, any number. So we say it's a constant. If then where C is any real number. Does everything make sense up to this point? Is there anyone here who doesn't understand what I just did? Don't be shy. Uh, but have you done derivatives? Asking the person who just messaged me. Have you done derivatives? Okay. Well, the derivative, if I ask you, if I give you a function and ask you to find the derivative, like what's the derivative of f of x? fx. The f of x is x cubed plus cos x plus 3x plus c. If you want to find the derivative, you do 3x squared, because that's how the derivatives work, minus sine x, because the derivative of cos is minus sine. Then derivative of 3x is 3, and derivative of c, which is a constant, is 0. So plus 0. But you don't need to write plus 0. So you got this. This is how it works. Do you understand that? Do you understand that much? Okay. Now, when you do integration, you need to do the opposite. You have a function, you need to work out what the original function, you got the derivative, you need to work out the original function. Does that make sense? Okay. So if f of x, if derivative of x is equal to 3x squared minus sine x plus 3, then f of x, the function itself, without with the derivative, is the integral of 3x squared minus sine x plus 3 dx. This is the notation for the integral. We have the function, we have the integral sign, then the function, and then followed by dx. And then the solution to that is, as we said, is x cubed plus cos x plus 3x plus c. Okay. And there are three basic integrals. There are three basic integrals here. Basic integrals. The integral of x to the power n dx is x to the power n plus 1 over n plus 1 plus c. And I'll do an example right away. So, example. The integral of x to the power 7 dx is x to the power 7 plus 1, so 8 over 8 plus c. The first one. The second integral is the integral of sine x dx is minus cos x plus c. Well, you don't need an example, it's just a given. 3, the integral of cos x dx is equal to sine x plus c, where c is any real number. It could be any number. So we say it's a constant. We just call it a constant. Um, does this make sense to everyone, especially those who haven't done integration in school yet? I think there were 2 people who said, okay, right. So the integral, like the integral of sine x, they are asking which function, when if you differentiate it, which function is sine x? Well, it's minus cos x plus anything, plus any real number, like minus cos x plus 8, for example. Yeah, because minus cos x plus 8, when if you differentiate, it's going to be sine x. If you do minus cos x plus 17 plus 17, it's still going to be sine x. Right. So any function that looks like this, Rag have, yes, we certainly do. A little bit later on. We certainly do. I can't remember when exactly we do this, but yeah. Basically, and first we need to do some basic integrals. And how it works is that the integral is linear. Some properties of integrals. Integral is linear. Of the integral. First, the integral is linear. Is linear. What does that mean? Well, that means that the integral of f plus g is equal to the integral of f plus integral of g. Well, of course, it could be minus. How do we use this example? Integral of x squared plus x cubed dx is equal to integral of x squared dx plus integral of x cubed dx. This is an important property. Integral is linear, and that's the first property, first linear. 2, the integral of k multiplied by f is equal to k multiplied by integral of f. Dx, of course, dx. That means you can take a constant out. Abiola, you don't need to integrate in 3D. You integrate in 1D. You just need to realize like you integrate it along the x-axis and you have a mass and you just need to take all this mass and put it into one point. So you replace this mass with a point mass of like m1, then m2. Does that make sense? So this is m1, this is m2, this is m3. It's along the x-axis. So you just think of it as like m1, m2, m3, m4, etc. And the mass is equal to the density times the volume, and the volume is equal to the width, which is dx times 2y. Becomes delta 2y dx, something like that. Hope that makes sense. 2y. Oh, sorry. If it's a circle, then it's not 2y. It's going to be pi 2y squared. If it's a cylinder. Yeah. Okay. Right. So you have example of that is the integral of 3 multiplied by x to the power 7 dx is equal to 3 integral of x7 dx. So these are the two properties. The sum of the integral of a sum is equal to the sum of integrals. And the integral of a constant multiplied by a function is equal to the constant multiplied by the integral of the function. So you can take, basically you can take out. This means you can split integrals. You can split the integral. And second means you can take a constant out. So these are the two properties of integrals. Now, let's have a look at this one. It seems like a complicated function, but actually it's not that difficult. You just need to make this into something more user-friendly. So you got 3 minus x squared cubed. You need to simplify that. And you can use the binomial expansion here. It's going to be 3 cubed minus 3 multiplied by 3 squared multiplied by minus x squared plus, so plus uh, 3 multiplied by 3 multiplied by minus x squared plus minus x squared cubed. And 3 is 27. That's minus 27x squared. This is plus 9x to the power 4. And this is minus x to the power 6. And now you need to find the integral of that 27 minus 27x squared plus 9x to the power 4 minus x6 dx. Put a dx. Like when you write dx, you imply brackets. Brackets are implied. So you normally drop them because you treat everything in between as as inside the integral. And then you just integrate, and you can. I'm going to do this in excruciating detail, so I'm very sorry for those who already know how to do this. I'm going to use the linearity of the integral. The integral is linear, so we have the sum of integrals. The integral of sum is equal to the sum of integrals. So I'm going to integrate them separately. So it's the integral of 27 dx minus the integral of 27x squared dx plus the integral of 9x to the power 4 dx minus the integral of x6 dx. And then the integral of 27, well, which function has a derivative of 27? Well, it has to be 27x. We kind of know that intuitively because the derivative of 27x is 27 minus. We can take 27 out, and we are left with the integral of x squared dx. Now plus, you take the 9 out, 9 integral of x to the power 4 dx. I'm using the second property of linearity. Okay, I can take a constant out. 9x to the power 4 minus x6. Well, x6 we can already do. So it's going to be x to the power 7 over 7 plus c. Now, technically, for each integral, I need plus c for each integral. But then I would have c plus c plus c plus c. Would it make it 4c? Well, not really, because c can be anything. So technically, it has to be c1 plus c2 plus c3 plus c4. So it's going to be 27x plus c1 right? Because we forgot C1, minus 27. Now, x cubed over 3 plus C2 plus 9 x to the power 5 over 5 plus C3 minus x7 over 7 plus C4. But we could just make a substitution. Let's say that C equals C1 plus C2 plus C3 plus C4. So we can replace it and say 27x minus 27 over 3, that's 9. 9x squared, x cubed, plus 9/5 x to the power 5 minus 1/7 x to the power 7 plus c. So I've combined all the c's together into one. Okay, and this is the answer. This is the solution. The integral is this. Check. Now I want to test. Check. I'm going to differentiate that and see if I end up with the same expression. So 27x minus 9x cubed plus 9/5 x to the power 5 minus 1/7 x to the power 7 plus c. I'm going to differentiate that. And 27x, that's 27, minus 9x cubed, so minus 27x squared. 9/5 times x to the power 5, there's plus 9 times 5, so 5 cancels, it's 9x to the power 4, minus 1/7, so it's 7. 7 over 7 is 1, so minus x to the power 6 plus 0. Okay, I think we're on a good track because that's what we had initially. That's what we had here. 27 minus 27x squared plus 9x to the power 4 minus x to the power 6. And well, it turns out that this can be written as 3 minus x squared to the power 3. So it works. Works. Any questions? Any questions here? Now this one, would you like me to do this one? Yes or no? Or do you think you understand how to do this? Yes or no? Would you like me to do it? Yes for yes, no for no. Okay, happy to do that. You need to well, to do this integral, of course, there's no product rule for integrals. Okay, there's no product rule for integrals, so you need to simplify the expression. So what I'll do is I open the brackets. All I need is to open the brackets. So there are different ways I can do this. Perhaps the easiest way is to multiply the second and third. So 1 minus x. And I'm going to multiply these two brackets. So it's 1 times 1 is 1, minus 3x, minus 2x, plus 6x squared dx. Okay, now I open these two. Well, I can combine the two, so it's minus 5x. So 1 times 1 is 1. 1 times minus 5x plus 6x squared minus x plus 5x squared minus 6x cubed dx. And now I can simplify that. 1 minus 6x plus 11x squared minus 6x cubed dx. Well, then I can integrate. The integral of 1 is which function, when you differentiate it, it gives you 1. It's x. Which function, when you differentiate it, gives you 6x. Well, that's going to be 3x minus 3x squared. I'm using this formula. X to the power n. Oh, hope you understand that. 3x squared. 11x squared, that's going to be plus 11 over, let's do it properly. So 11 multiplied by x cubed over 3. And here, let's keep it simple. Minus 6x squared over 2. 11x squared over 11x cubed over 3. Minus 6 x to the power 4 over 4 plus c. You just simplify it slightly. So x minus 3x squared plus 11 thirds x cubed minus 6 over 4, that's 3 over 2. 3 over 2 x to the power 4 plus c. That's it. That's the answer. So which function, when you differentiate, it gives you this, and it's this. You can test it. I'm not going to do that right now. You can check. Check. Okay, this one, problem 3. It seems horrible, but if you remember the property of the integral, that the integral is linear, it becomes quite simple. So there's nothing scary about it. It looks horrendous. All you need, so there's a square, so you open the brackets. So the integral x, open the brackets, so it's going to be square root of 2x squared minus 2 times 2x multiplied by cube root of 3x. I'm using the formula a plus b, a minus b squared is a squared minus 2ab plus cb squared. As simple as that. And then plus cube root of 3x squared. Okay, so it doesn't look pretty, and it's not particularly pretty. You just need to simplify it. So 2x squared, square root of 2x squared, that's actually just 2x. Very simple. That's easy. Now this one. So I'm going to separate the numbers from the x's. So it's going to be 2 square root of 2 cube root of 3 multiplied by square root of x. Square root of x is x to the power a half multiplied by cube root of 3, x to the power 1/3. Plus, now cube root of 3 squared, cube root of 3 squared, multiplied by cube root of 3 squared, so x to the power 2 over 3. And this is x dx. Carry on. So it's going to be 2x minus 2 times square root of 2 times cube root of 3. There's nothing you can do about it, really. I mean, it's just a number. It's not a pretty one. 2 square root of 2 cube root of 3. But you can simplify this. So x to the power half times x to the power cubed, it's going to be x to the power 5/6, because when you multiply powers, the indices add up. X to the power 5/6 plus. Now this is cube root of 3 squared. Well, you could simplify it technically cube root of 9. Why not? Multiplied by x to the power 2/3. Now all over x dx. So what you do here is you split them into 3 different fractions. It's going to be 2x over x minus 2 root 2 root 3 x to the power 5/6 over x plus cube root of 9 x 2/3 over x dx. And finally, it's the integral. 2x over x, that's 2. This is x to the power 5/6 over x. And so you subtract the powers, and it's going to be minus 2 root 2 cube root of 3 x to the power minus 1/6. And this one plus cube root of 9. And then it's going to be x to the power minus 1/3, because that's what it is. X to the power 2/3 minus divided by x is x to the power minus 1/3 dx. And now you can finally integrate. The integral of 2 is 2x. And then for this, you use the formula. So minus 2 root 2 cube root of 3. X to the power minus 1/6 plus 1. So that's going to be x to the power 5/6 divided by 5/6 plus cube root of 9 x to the power 2/3 divided by 2/3 plus c. And then you can just simplify that slightly. So 2x minus, so 5/6, so you divide by 5, so it's divided by 5 times 6, so it's 12 square root of 2 cube root of 3 over 5 x to the power 5/6 plus 3 cube root of 9 over 2 x to the power 2/3 plus c. And that is the answer. Any questions here? Anything you're confused about? So I've shown you how to simplify the expression under the integral, and how to just use the basic integration rules to integrate that. So do practice, do some practice runs, and these are the first few expressions. The next thing which we're going to do is integration by substitution. And integration by substitution. It's quite a complicated example. So let me do a simpler one, perhaps. Let's think integration by substitution. substitution. By substitution. So how does that work? Let's say you have an integral of x multiplied by 3x squared 6x multiplied by 3x squared plus 7 to the power 5 dx. Looks scary. Okay, the integral looks scary. You could potentially use binomial expansion here and then just multiply it out. But this would take you a long time. So let's make it ridiculous. Let's make it 55. So you wouldn't dream of doing a binomial expansion. Yes, the coefficients would be in the gazillions. So what you do is you perform a substitution. Now, when you do substitution at A level, they normally tell you what the substitution is. But at COMPOS, we don't. We don't tell you what the substitution is. You have to work it out for yourself. And that's a whole art. Like learning to do integration by substitution, that's probably half a year of a university. So if you go to university, you'll do this for a half a year. And you won't even be close to being able to integrate anything, any function. If you look at the table of integrals, they are enormous tables of integrals. So it's a table which contains all the integrals you could think of, and they are just very, very, very big. So the substitution, what do I do here? I say, well, let's say substitution, let u, it's a new letter, equal, I like this expression. I wouldn't substitute 6x. It doesn't make any sense to substitute 6x. So at some point you just start you get a feeling for those things. You substitute this expression. Let u be equal 3x squared plus 7. Then du, we find the derivative, du on dx. We differentiate that expression, and we find that, oh, it is in fact equal to 6x. So here we can express dx from here. And that means that dx is equal to du over 6x. All right, let's substitute that in and see where that takes us. Perhaps takes us to a nicer place. So it's the integral of 6x. We don't know what to do with 6x yet. Multiplied by 3x plus 7, but 3x squared plus 7 is u. So that's u to the power 55. And then dx is du over 6x. So multiplied by du over 6x. Now we still have x left, so we cannot proceed because we haven't done a full substitution. Substitution has to be full. Substitution has to be full. That's important. So you cannot leave x. But incidentally, it's a very beautiful thing because either 6x and 6x cancel out. There's no x left, and now we have a very simple integral. We have the integral of u to the power 55 du, which we can do. It's a integral. It's the first integral they teach you. It's that's u to the power 56 divided by 56 plus c, of course. Now, what is u? Well, whenever we do reverse substitution, u is 3x squared plus 7. So it's going to be 3x squared plus 7 to the power 56 over 56 plus c. Ta-da! But we've just found the integral of this expression using a substitution. How well do you understand what I have just done? On a scale of 0 to 10, please. Oh, very good. Impressive. Right. Tom, anything in particular? Any particular part you are confused about, or is just anything you can ask? Which
No, it's just my first time doing it, so
okay.
I'm
But
still working it out.
you'd be able to you can follow all the steps, right?
Yeah.
Okay, you can follow the steps. That's good. All right, so let's try a harder problem. This one, and as you can guess, we substitute not x to the power 5, but this thing. So we substitute. I like to draw this. You don't have to draw. You don't have to do it this way. I like to draw a vertical line, vertical squiggly line, and say u is equal to 2 minus 5x cubed. I differentiate du over dx. Why do I differentiate? Because I need to replace dx as well. All right, so I need to replace x here. I need to replace x here, and I need to replace x here. So du dx is, I differentiate that. So that's minus 15x squared. And I can work out dx from here. So dx is du over minus 15x squared. I don't know what to do with x to the power 5 yet, because there's no beautiful way. I mean, I could technically express x here. I would say x is equal to 2 minus u divided by 5, and then cube root, and then x to the power 5 would be this thing to the power 5. It doesn't look good. The aim is to make it simpler, not introduce fractions with radicals. So I substitute what I have, keeping in mind that I'm not allowed to proceed until until the substitution is full, until there is no x left, because I'm not allowed to keep x. So integral x to the power 5 multiplied by 2 minus 5x cubed, that's u to the power 2/3 multiplied by dx, and dx is du over minus 15x squared. All right, x squared, okay, I can cancel that. X squared cancels, and I have x cubed. I like x cubed much more. X cubed because that's doable. I can express x cubed. So x cubed, that's u, 2 minus u, 2 minus u. So 5x cubed is 2 minus u. So x cubed is 2 minus u divided by 5. That's much more pleasant. And I can do integral of 2 minus u divided by 5 multiplied by u to the power 2/3 du. My substitution is full because there is no x left. I am allowed to proceed with the integration. I take 1/5 out. So 1/5 comes out of the integral. And it's have 2 minus u times that. So it's going to be 2 u 2/3 minus U times U 2/3, that's U 5/3 du. So 1/5 multi 1/5 multiplied by 2 U 2/3, that's going to be 5/3 over 5/3 because I'm using the plus one formula. So 2/3 plus one is 5/3, just in case. I hope it is. Yes, it is. Would be embarrassing. And then minus U to the power 5/3 plus one is 8/3 over 8/3. And then just simplify the whole thing. It's going to be 2 times 3, so it's 6. 6 25ths. 25ths U to the power 5/3 minus 3 40ths, because 5 times 8 is 40. 3 goes on top because we're dividing by 8/3 when you divide by a fraction. Be over 40 U 8/3 plus C, of course. Caden, yeah, you've stumped me with that question. Um, I'm thinking about it. I'm thinking how to best answer that question. Okay, 6 over 25, U to the power 5/3 minus 3x, U over 14. Oh yes, I've lost the minus 15. Thank you. Minus 15. So that's minus 75 minus 75. 5 times 15, 75, yeah. And then so that's not 25. That's in fact, it's 75 times 5, 225. 75. Oh, 375. But with 3 cancels, 25 times 5, 125, 2. So 325, 2 divided by 125. So 2 divided by 125 with a minus, and then plus 25, 8 times 25. 8 times 25 is 200. Okay, I think that's better. 1 over 200. Okay, and then uh, minus 125, so it's minus 2 over 125 multiplied by u, which is 2 minus 5x cubed. 2 minus 5x cubed to the power 5 over 3. plus 1 over 200 multiplied by 2 minus 5x cubed to the power 5 over 3. And 8 over 3 plus c. Okay, I think that's it. So we've managed to do this integral by substitution. Now, answering your question, well, it's not just notation, Caden. It's because if you remember, the derivative is the gradient. If you have a function, this is f of x. If you take the gradient, this is delta y, and this is delta x. The gradient is delta y over delta x. But what you do is you are making the delta x smaller. So the limit as delta x tends to 0 of delta y divided by delta x. So what you're doing is you are closing in. So you're making delta x smaller. So the line becomes this, then this, then this, and finally it becomes the tangent, which is dy over dx. So it's a small change in y divided by a small change in x, and that's equal to the gradient of tangent, which is a, well, the tangible value. It's the derivative. It's the f of x. So dy over dx is division. It's not just notation. It is division, but it's division of infinitely small values. But you can use it as division. Therefore, dy can be expressed as the derivative of the function multiplied by dx. And dx can be expressed as dy over the derivative of the function. And you can go further with this. You can say dy dy can be written as dy over dx multiplied by dt multiplied by dt, and you can place that in, and you can say, or you can do all sorts of things. But fact of the matter is that you can use it as division, even though it is notation. But what you can't do is treat it as multiplication, because some people multiply d by y. That's not true. It doesn't work like that. D is a way to show infinitely small change. D is an infinitely small change of y, whereas delta y is a change. Delta y is a change in y. Dy is an infinitely small change in y. Does that make sense, Caden? Does that answer your question? Okay, good. All right, this problem. Um, does anyone think they can do this one? Uh, do you think you're confident in doing this? It's substitution again. Nice. Well, I'll give you 1 minute. I just have to pop out for a sec, and think about it. And try to do it yourself while I'm away for just 30 seconds. I'll be back. Okay. So yes, Charlie, you're correct. Let U be sine x. Uh, okay. U is sine x. Um, U is sine x. So du dx, the derivative, is cos x. So that means dx can be expressed as du over cos x. All right. Well, let's see. Let's see. I haven't done this one before. Okay, so it's cos 5x multiplied by u to the power half, because that's square root of u, multiplied by dx, which is du over cos x. Cos x cancels, and you got integral of cos to the power 4x multiplied by u to the power half du. Okay, so it's slightly harder than I expected. But cos to the power 4x, that is, well, trig. You know that cos squared x is 1 minus sine squared x, which is u, 1 minus, which is 1 minus u squared. Therefore, cos to the power 4x, it's 1 minus u squared squared, which is 1 minus 2u squared plus u to the power 4. And that's what we do here. So it's going to be the integral of 1 minus 2u squared plus u to the power 4 times u half du. Now the substitution is full. Now I'm allowed to integrate because I have no x left. I'm allowed to integrate, so that's going to be u to the power half minus 2u to the power 5 over 2 plus u to the power 9 over 2 du We integrate that, it's going to be u to the power 3 over 2 divided, so it's 2/3, u 3 over 2, minus 2, so there's 4. Oh no, sorry. U to the power 7 over 2 divided by 7, 4, that's fine, plus u 9, 2, that's going to be u to the power 11 over 2, 11, 2, plus c. Yeah. Well, I didn't realize that until I started doing it, so um, I saw the method. Sometimes you're just stumped and you don't know what to do next. In that case, Wolfram, Wolfram Alpha. Okay, a very useful tool. And yeah, and then you just reverse the substitution. So it's sine u is sine x. So you reverse substitute. So it's going to be 2/3 sine x to the power 3 over 2. And then minus 4/7 sine x to the power 7 over 2 plus 2/11 sine x 11 over 2 plus c. Beautiful. Right. Now let's do integration by parts. Integration by parts, it's a very useful formula. So integration by parts. Integration by parts. And I'll try to derive the formula, and I'll try not to embarrass myself. And so integration by parts. You know, we start with the product rule. The product rule says that uv, the derivative of uv, is u dash v plus uv dash. So you could write that u dash v can be written as uv dash minus uv dash. Now we integrate both sides. So we integrate integral of u dash v equals the integral of uv dash minus the integral of uv dash dx, of course, dx. Now we remember what is oh, no, that's it. U dash v dx equals the integral of the integral of a derivative is the opposite. The integral of the derivative of the opposite, so it's going to be uv. And then minus the integral of uv dash dx. And that's the formula for integration by parts. Well, what I've done, so integrate both sides. I've done this, and then I've used, because the integral is the antiderivative. So the integral of f prime is f. That's how it works. The integral of a derivative of a function is the function itself, because the integration and differentiation are the opposites. Okay, so how do we use that? Well, let's look at this example. Sorry, just I'll check one thing. Integration. I think it's usually written as a v. Yeah, it's uv dash. So what they do is they do it in the opposite order. So when I did this, I expressed u dash v. So I'm just going to switch those round. So I'm just going to take this to the left and this to the right. So the integral of u v dash dx. So I'm just rearrange it. Nothing serious. Is uv minus integral of u dash v dx. So we're going to use this formula. They're equivalent. They're identical. It's just a different order of things. So you write down the formula, and it's it's sort of a substitution in a way, but easier. You need to decide which is which. So you have a product of two things. You have x and you have cos x. You need to decide which one of them is u and which one of them is v dash. There is a method to the madness, but I'm just gonna guess. I'm just gonna guess here. I'm gonna say, okay, let's say this is u and this is v dash. V dash. Okay. So I write them out because that's gonna be useful. U is x. U dash, because we will need u dash. What is x dash? Well, it's gonna be 1. Right? Because the derivative of x is 1. Now we know that v dash is cos x. So what is v? What is the derivative? What is v? If v dash is cos x, it's sine x. Yes, sine x. Very good. So now we use this formula. So the integral of x cos x dx, because we already know that this is u and this is v dash, is going to be uv, which is x sine x, minus integral of u dash, which is 1, multiplied by uh, v, which is sine x dx. So what I've done, just write it here. I sort of use the product rule here in a way. There's no product rule for integration, of course, but there is a consequence. There's a formula of integration by parts, which is a consequence of the product rule. And yeah, so we have x cos x, x sine x minus. So we don't need to integrate that. It's already here. And we integrate this very easily. So it's x sine x minus integral of sine. So it's plus cos x plus c. And that's the answer. Straightforward. Do the same thing here. We write down the formula of integration by parts. uv dash dx equals uv minus the integral of u dash v dx. Now we need to decide which one is u. Well, a rule of thumb, if there's an x, in most cases, it is u. If there's an x, there's a power of x. In most cases, that is u. So we're going to say that this is u. It works except if there's a logarithm. If there's a logarithm, it's the opposite. And this is v dash. So u is x squared. U dash is 2x. V dash is sine 2x. So which function has a derivative of sine 2x? And it turns out it is 1/2 cos 2x. No, u is x squared. It's squared. Yeah, sorry, it's just a poorly written 2. Okay. U is x squared, so u dash is 2x. So we're going to use this formula. So the integral of x squared sine 2x dx is going to be equal to uv, which is x squared, multiplied by 1/2 cos 2x. Now, minus the integral of u dash, so that's 2x, multiplied by v, which is 1/2 cos 2x dx. So if we simplify that, that is x squared over 2 cos 2x minus, so 2 and 2 cancel, integral of x cos 2x dx. Now, we don't know how to solve this integral, but we need to do it by parts again. So it's another integration by parts. So x cos 2x dx equals. Now, once again, this is u, and this is v dash. So u is x, u dash is 1, v dash is cos 2x, and v is it's 1/2. Oh, I messed it up. It is minus 1/2 cos x. So it's minus, and this is going to be plus. So minus and plus. Okay, anyways, cos 2x is 1/2 sine 2x. Because if we differentiate 1/2 sine 2x, we get cos 2x. And then so it's uv, that is going to be uv, so it's x multiplied by 1/2 sine 2x minus integral of u dash, so 1 multiplied by v, so 1/2 sine 2x dx. All right, beautiful. Now, this is x over 2 sine 2x minus 1/2 sine 2x. So 1/2, the integral of sine 2x. So which function, when differentiated, gives you 1/2 2x? Well, it's going to be minus 1/2 cos 2x. Because the derivative of minus 1/2 cos 2x is sine 2x. Sine 2x. plus c, of course. So that is x over 2 sine 2x plus a quarter cos 2x plus c. And you can sub that into here. So it's going to be minus x squared over 2 cos 2x plus x over 2 sine 2x plus 1/4 cos 2x plus c. And that is the answer. So we did integration by parts twice. We did it once, and we've reduced the power of x. It was x squared, now it's x. And then we did it again, and then we arrived to the final answer. It's how many times you need. If you get x squared, if you do integral of x cubed sine x, for example, you'll need to do it 3 times. You will need to use the integration by parts 3 times. So this is going to be x cubed cos x minus integral of 3x squared cos x. And you're going to see the power it reduces by 2, and then you can carry on. Tabular method. What do you mean by tabular method? You can DI table. I'm not sure what you're referring to, so I can't comment. There's a table of integrals, if that's what you're referring to. Table, you can use tables of integrals, tables of standard integrals that you can use. But yeah, probably not that. I can tell you that integration is such a vast topic. I myself having studied it for 7 years at university, probably know maybe 10% of it. Uh, oh, okay. Well, shortcut of integration by parts. Yeah, you can invent whichever method. There are different ways you can shortcut. I prefer this shortcut myself. So I use a simpler formula. Here I say, well, V dash is, you know that V dash is dv dx times dx equals uv minus integral. U dash is du dx v dx, and then dx cancels, and you are left with integral of u dv equals uv minus integral of v du. Now this is a shorter way. I like it better, but it's not that easy to get your head round. It takes time. It takes time to realize that you, what to do here. Okay, for problem 12 in maths, let's have a look at problem 12 in maths. we we do expect you to use this method, but you don't have to. I mean, we do expect you to use this based on this example. Okay. Um, for B, 12B, problem 5. Oh, all right, quarter of a circle. Expectation. Let's have a look. And we're talking about a circle of an arbitrary radius. Uh, let's have a look. So you have a circle of radius r, and for the area. Okay, so this formula, so y is going to be square root of r squared minus x squared. So it's the integral of r squared minus x squared dx from 0 to r. I got the integral of 1/2 x times u, or half. No, no, you can't really substitute it like this. You need to use this result. So if you use a substitution, u equals r squared minus x squared, du over dx is minus 2x, dx is du over minus 2x. That doesn't take you anywhere. Yeah, you kind of need to use this. You need to modify this relation for an arbitrary. So how would it look like if this was r squared? So that's what you need to work out. It's a bit of trial and error, perhaps. See if you can do it. It's not that simple. Have a have a go. That's yeah. It's not an easy question. All right. I'll finish here. It was great seeing you back, and I'll see you next. I'll see you next week. See you, everyone.